Hello everyone. I keep on redoing these template videos just because I always think templates are more convoluted than they're always a convoluted topic, or I'm not making my points clearly enough. So I wanted to do one more try of this. I have a version of the linked list class yet again. I have more advanced version of this in later lectures in other lecture series, but I just want to do the very, very, very bare minimum linked list, templated linked list class. So here is my starter code. That starter code is available to you guys already on the in-class code repository folder for under module 10 simpler template starter. Okay. Not a whole lot going on here. We have a linked list node, we have a linked list class. So here are the functions of my linked list class. I have an add. I can add it I think it's always to the end. I can get the size of my linked list with a length, how many nodes there are. I can get a particular item at a particular data point, and I can print out the whole thing. Now, there's a whole bunch of other things I could do, but I've stripped those away. I got rid of the doubly linked list. I got rid of the, although this has a head and a tail as well. I got rid of a lot of the other versions or parts of linked lists. I got rid of the iterators, for example. Just the bare minimum. I have these bunch of nodes that string one after the other. I've already done the code for this, so I'll show you what this looks like. But here's what linked list.h looks like. You know, I have a bunch of functions, and then they're actually defined over here. Notice that linked list I have a head and a tail, and I have a bunch of nodes. And inside the nodes, each of these nodes, I have a data, and I have a next. And the data we were putting in there, we had this linked list data type. And I said, well, I don't want to be very specific. I'm just going to make some generic data type that just happens to store an integer. I'm going to do one better. So let's see what this looks like with the non-generic linked list data type. So here, notice I don't even have the CPP files anymore. I have two data files, linked list data and linked list data 2, but we're going to ignore this linked list data 2 as well. Let's just jump to linked list. Again, the pattern is I'm going to have a linked list. I'm going to say it's templated up at the top. The class is templated. So everywhere you see a T, it's this templated class. Okay. My linked list class, here's me setting things up. That's fine. Here's my destructor where I delete all of the nodes in my class when I'm done with them. Here's me printing out a list. Notice when I get one of the nodes, I have to say it's a node, a templated node, so it takes in a T, right? So this is a pointer to a templated node that takes in data type T. The same data type as my linked list. That's the reason we have to have that T there. We have to associate the T for this linked list node is the exact same T as for a linked list. Here's me adding stuff. I get a particular node. It's a node of type T, containing type T, data of type T, and it's a pointer to a node that contains T. Here's me making a new linked list node containing type T, and the data is of type T. Hey, look, right here, my input, instead of saying it's a linked list data item, it's a T. What's T? I don't know. I'll figure it out later. That's what the template class templating is for. I don't know what T is. I don't care what T is. I will figure it out later. That's what this ultimately is doing for us. It allows me to put a wide variety of different things, and I will make brand new classes for each of the different kinds of classes I have shoved onto this kind of linked list. So that I don't have to manually make and copy and paste my code a bunch. I just make it so that it takes in data of type T. As long as the classes adhere to that particular standard, the series of calls, I'm fine. So, and everything is in my header file, not in my CPP file. So here is get size, for example. I get the current node, and then I walk down my log. This code has not changed at all. All I did was, instead of linked list node, I have linked list node holding in a T, and that's it. There's nothing else. Right? There's no, every time instead of LL data, it's now saying T, but it is a find and replace. Everywhere I have linked list node, it's a templated class, and every time I have LL data, I put in T. So nothing new necessarily here. Here is linked list node.h. So I'm going to make a linked list node that takes data of type T, and it will make and will store it. Here's my destructor. Here is toString. All it does is let's make sure I'm doing it right. It is going to take a data type, and then it calls the function toString. If I do not have a function called toString, I cannot store it in this linked list node. That's the key. That anything I store in this thing, every time I use one of these data items, data toString, for example, like here, or if I use, I'm trying to think of what other places I might need it. I'm using T here, so I need a constructor that takes in a value out, and that can your data has to be able to call to get value. So this function needs to be implemented in whatever data type you're storing here. And I also need a constructor that takes in a value from this thing. Okay. Everywhere I have, so this is going to give me a linked list node pointer. I'm surprised it didn't yell at me for needing it being to be templated. But so I can say what the next is, and I can add the next. That's fine. This should all compile. It should all work. The data itself being stored is a type T. So here we go. I'm just going to compile my code. I'm going to print it off. My test case though is this. I'm going to ignore the comments for now. I'm going to make a linked list that stores in it LL data, objects or data of type LL data, which just happens to be things that store integers. So it takes in, this thing stores data of type LL data. I then have a for loop. I'm going to add a bunch of data items, and those data items are just going to be the next number. So it's going to be 0, 1, 2, 3, up to 20. And then I'm going to print off the whole thing when I'm done. Boom. All right, here's me deleting all my nodes at the end. Here's me printing off that linked list. My elements in my linked list are 0, 1, 2, 3, 4, all the way up to 19. That's it. I make a whole bunch of nodes with certain LL datas in them, and then I print them out at the end. Here's why I'm bringing all this up and why I left these comments in. There is nothing new, well, very little new here. I did effectively nothing different. I have a new linked list called LL2 because I'm very original. It stores linked list data 2. I don't know what that class is. I just know there's a class called LL data 2. I'm going to do the same thing as I did last time. I'm going to make a LL2 data item like I did it up in the line above. Make a new data item. I add it to linked list 2, and then I'm printing off linked list 2. Nothing's changed. Like, I'm calling the exact same thing. I'm just storing something different in my linked list. And here's what linked list, where is linked list data 2? There we go. Linked list data 2 is actually storing a string. It's not storing an integer at all anymore. It's storing a string. Why? Because I wanted something simple. It has blank constructor. It has a constructor with a parameter, a string parameter, because that's the value. I have a function called getValue. I have a function called setValue. I have a function called toString. And here's all the code for it. It looks almost exactly the same as linked list data, but instead of an integer, I'm storing a string. And if I run this thing, there we go. If I run it, watch what happens. Hopefully it's all going to happen fine. All right, this is me cleaning up stuff at the end. That's what I get. I'm adding this string hello to each of the nodes. I make a linked list with 20 nodes in it. Each one of those nodes stores essentially a string hello. And it doesn't matter. I didn't have to redo any of my code there. I did have to make another data structure, but that's simply because I needed it to show this in action. as long as it fits a particular pattern, like, oh, you need to compare two values, for example. That's what the standard template libraries require, the greater than operator. As long as it fits this, has a series of function calls that you need, you can store it in a templated class. That's the point. So I'm not reinventing the wheel each time. I'm just reusing my old code. The templated class allows me to sort a wide variety of different classes in there without having to duplicate my code over and over and over again. So I have two different classes being stored in the linked list class, and I'm none the wiser. Right? I didn't have to make it specifically for this type of data. I can make it so it can store almost any kind of data, that as long as it fits a certain pattern. That's what I wanted to show. This code example is also available to you guys, and then we're going to do a more elaborate example next. All right, thanks everyone.